All right. Good day to you. We're going to look at solving systems of equations using substitution. So this method becomes very, very helpful when you don't have access to something that you can graph, whether it be by paper pencil or a calculator. You still can solve a system of equations, meaning you can still find the point where the two lines cross without those two items, and I'm going to show you how. So we have a couple of steps or process that we need to follow in order to get to our solution. First, if a variable is not isolated, you need to isolate a variable. Secondly, once you isolate that variable, whatever that variable is equal to, you're going to take what it's equal to and substitute it inside the other equation. And then you're going to come up with an answer. Once you get that answer, you take that answer and substitute into either equation to find your solution. Now, in words, that sounds really confusing, but it isn't. I think you're really going to like this method. So let's go ahead and start. Solve using substitution. Y is equal to -1. Yay, we don't have to do anything. Y is already alone. So what we're going to do is we're going to take -1 and we're going to put it right here in place of y, because we know that y is -1. So we've got 2x plus 9. We know this means multiplication. So 9 times -1 is equal to -13. So we've got 2x, well 9 times -1 is -9, equals -13. We want to get the x term alone. So let's add 9 to both sides of the equation. And we're left with 2x is equal to -4. We want x alone, so divide by 2 on both sides of the equation, and x is -2. So what we now know is that x is -2 and y is -1. So the ordered pair that makes both equations true would be -2, comma, -1. All right, so let's move on. It was just that simple. Now on this one, it's like, what? Miss Clark, there's no variable alone. Well, one of the things about solving by substitution that's really, really very neat is that you can pick what you want to do. Now, I could solve this first equation for either x or y, but what I see automatically is if I solve for x, I'm going to get a fraction over here. Because then I would have to divide 9 by 7. If I solve for y, then I'd have to divide 7 by 9, or vice versa. So I don't want to do that one. Do I mind working with fractions? No, I don't. I like them a lot. But you might mind working with fractions. So what we're going to do, instead of working with fractions, I noticed that 3, 6, and 9 have something in common. Well, 3 times 2 is 6, and 3 times 3 is 9. So if I use the second equation, I'm not going to get a fraction if I solve for a variable. So what I'm going to do is I am going to solve for x, meaning I'm going to get x alone. So I'm going to take -3x minus 6y equals 9. And I'm going to add 6y to both sides of the equation. And that leaves me with -3x equals 6y plus 9. I want x alone. So I'm going to divide by -3. All three terms, and that leaves me with x is equal to -2y minus 3. So now I know the value of x. And it might look strange to you because it's not a number, but it's okay. So I'm going to say wherever I see x, I'm going to put this in instead. But I'm not going to use the equation that I solved to get x. I'm going to use the second one. So, or the first one, excuse me. So I've got -7, and where I see x, right here, I'm going to put in -2y minus 3, and then I'm just going to finish it out. Minus 9y equals negative 4. Then I'm going to do the math. So I've got negative 7 multiplied by negative 2y, that's 14y. Negative 7 multiplied by negative 3 is positive 21. So basically, I just used distributive property. Minus 9y is equal to negative 4. Now I'm going to combine like terms right here. So 14y minus 9y is 5y plus 21 equals negative 4. I want y alone. So I'm going to subtract 21 from both sides of the equation. That gives me 5y is equal to negative 25, meaning that y must be negative 5. Okay, so we've got one answer and one answer only. Well, we know what y is. Now we got to find out what x is. So what you're going to do is you're going to choose either equation, whether it's the top one or the bottom one, and you're going to substitute negative 5 where you see y. That's kind of funny, where you see y, not y. But, so we're going to take negative 5 right here, and let's go ahead and use the second equation. So I'm going to put negative 5 right there. Now, could you use the first one? Yes, you could. I'm not going to because I want you to see what it looks like. So I'm going to put a little box right here. And I'm going to do negative 3x minus 6 times negative 5 equals 9. So I've got negative 3x plus 30 equals 9. Subtract 30, subtract 30. That gives me negative 3x equals negative 21. Divide by negative 3. Divide by negative 3. X, therefore, is 7. So the ordered pair that makes this true is 7, comma, negative 5. And I think I'm doing a lot of boxes here, so why don't we do something like this so you'll know where the answer is. The only thing about these boxes, they get smaller and smaller. Anyway, let's move right on. So here we've got y is equal to negative 2x plus 4. Y is equal to negative x minus 3. Well, if y is equal to this and y is equal to that, that means that I can take this y equals and I can substitute. In other words, I can put negative x minus 3 in place of this y and set them equal to each other. So now it's just a simple solving of the equation. So I'm going to add x to both sides of the equation, and that leaves me negative 3 is equal to negative x plus 4. Well, I want x alone, so I'm going to subtract 4 from both sides of the equation, and that gives me negative 7 equals negative x. But I don't want negative x. So what I know is that there's an imaginary 1 in front of this x, so that means I've got an imaginary negative 1. So I'm going to divide both sides by negative 1, and that leaves me with x is equal to 7. So then I take the 7 here, and I use either equation, and I substitute. So I'm going to put it here. So I've got now y is equal to negative 2 times 7 plus 4. y is equal to negative 14 plus 4. Y therefore is equal to negative 10. So now what I know is that the ordered pair that makes this true is 7, negative 10. Now one thing I haven't mentioned is, well, Ms. Clark, how do you check it? How do I know that I'm right? Well, if I take the x and the y, just remember like when we were doing earlier and we were trying to say, is this ordered pair an answer to the system of equations? Well, we know that when the ordered pair makes both equations true. So if I put 7 in place of x, I get negative 7 minus 3. Well, what is negative 7 minus 3? It's negative 10. So I had already figured that out here, so I don't have to test that. But that's one way that you can make sure that you're right. So let's go ahead and I'm going to continue. And then you've got one that's your turn. So I've got x plus 9y equals negative 2, negative 3x minus 6y equals negative 15. And remember, our first step is to solve or isolate a variable. Now, if you notice here, this one would be pretty easy to get x alone. So let's just do that one. So we're going to do x plus 9y is equal to negative 2. So I'm going to subtract 9y from both sides of the equation. And that leaves me with x is equal to negative 9y minus 2. So x is already alone. So now I'm going to come to my second equation. And where I see x, I'm going to put in this expression. So I've got now negative 3 times negative 9y minus 2 minus 6y equals negative 15. So I do the math. 27y, because I'm distributing the negative 3 to both terms inside the parentheses. So 27y plus 6 minus 6y equals negative 15. Combine these like terms here. So that gives me 21y plus 6 equals negative 15. Subtract 6 from both sides of the equation. We've got 21y equals negative 21. Therefore, y must be negative 1. And again, it's not that I didn't know what I was doing. I did skip that division because by now we should know that that's what we do as the last step. So now I'm going to take y and I'm going to substitute and solve for x. So I could pick either equation, it doesn't matter. I'm going to pick the first one. So I've got x plus 9 multiplied by negative 1 equals negative 2. So x minus 9 equals negative 2. I'm going to add 9 to both sides of the equation. X therefore is 7. So our ordered pair that makes this true would be 7, negative 1. This is our answer. All right, and then again we've got y equals 6x minus 3 and y equals negative 4x plus 7. What I know is that I can replace y in the first equation with the value of y from the second equation, set them equal to each other. And then solve. So I'm going to add 4x to both sides of the equation. And I've got 7 equals 10x minus 3. I'm going to add 3 to both sides of the equation because I want the x term alone. So now that I've got the x term alone, I want x completely alone. So I'm dividing by 10 on both sides of the equation. Therefore, x is equal to 1. And I'm going to take this 1 and use either equation. Substitute that value of x in to find y, so I'll just use the second one. Y is equal to negative 4 times 1 plus 7. Y is equal to negative 4 plus 7. I'm sorry, I just lost my train of thought. Y is equal to 3. So, let's check it to make sure. Because I feel like maybe, well, let's just check. If I put in x for 1 here, 6 times 1 is 6, minus 3 is 3. That's good. If I put in negative 4 times 1, that's negative 4, plus 7 is 3. Okay. So, 1, 3 would be my answer. All right, it's your turn. Go ahead, and I'll be back with the answer. All right, here is your answer to your substitution problem. Again, if you have any questions at all, please don't hesitate to ask. I'll talk to you later. Bye-bye.